Yeah, I'm going to talk about BEHAT a bit. More than 3.5 years ago, actually, I stumbled upon this really interesting Ruby tool called Cucumber. And wow, I thought, that's an amazing way to teach your product owner how to test things, right? So since then, I did my own research and tried to make Cucumber work in PHP. It didn't work because Cucumber is a Ruby tool and PHP is PHP. I then went and started to see how with minimal amount of effort I can bring whatever Cucumber does for Ruby into the PHP. So I quickly wrote Gherkin parser, which is just plain text, and started to look how I can hook this parser into PHP unit. And I don't know how it is right now, but back then it was quite hard to hook anything into PHP unit. And so I looked all over the places, and it was really, really hard to find a way to not create testing framework from scratch, right? There was no way for me to just hook this Gherkin parser into anything. And so I started to write this new testing tool, which will become BEHAT. And the day I started doing that, I kind of promised to myself that whatever will come up later will be layers or levels more extendable than what there was on the market. So idea was not only to create this tool that was kind of acting like Cucumber. It was to create a tool that others can take, extend, or change it in the way they want. So the other guy that comes up with different language, not Gherkin, and wants to just add it to the sum testing tool without bothering about it, he can just take BEHAT and change it. So I am at Everz, everywhere you can find me. I spent more than 7 years now writing software. And I also spent more than 4 last years learning about businesses, mostly thanks to developing BEHAT. Now I'm filling the gap between the two by being BDD practice manager at one of the best companies in the world, which is partly responsible for doing this amazing event. Partly. So what is this talk about? Obviously, it's a SymfonyLive, so this talk will be about Symfony. It will be less about Symfony as a framework and more Symfony as a components set, but I will specifically go into details about how to use those things in the framework, how to use it in the bundles, right? So principles are applicable all over the place. This talk is also, as you could imagine, about design patterns. Not about all of them. The point of this talk is not to go through every design pattern and describe what they do. You have plenty of books for that, including Gang of Four. We will mostly go through structural design patterns, orange ones on this map, and not all of them, but only the ones that I found usage for in the last 4 years of development of BEHAT. It is hard to talk about design patterns without actually seeing an example, because design patterns are abstraction technique. And as we learned from Kuba's talk, premature abstraction is a root of many evils in the modern design. And you cannot apply design patterns without having a problem that those design patterns solve. So heck, thought I, where do I find a code base that kind of uses design pattern in a really interesting way that will be interesting for attendees of SymfonyLive? That's where BEHAT comes in. Now, little side note, this is a decoupling with design patterns talk. I would not talk at all about BEHAT as a tool or BEHAT as a BDD methodology. I will talk about BEHAT as a code base I wrote and continue writing throughout 3.5 years. I will talk about the principles that I used inside, mistakes that I did, and how you can apply them in your applications in order to achieve the similar results that I achieved with BEHAT. So don't take anything as bragging. I did a lot of interesting and smart things. I did a lot of stupid things and mistakes, and I will mention a couple of them throughout the talk. So look at those principles, look at the problem I'm solving, and maybe there will be something you can apply to your projects that could help you to make your design more explicit and better. Okay. So 2 years ago, I started with this thing called BEHAT 3, because BEHAT 2 had a lot of limitations, mostly in design. And again, even though at the very, very beginning I said, like, I want to create something very extensible, there was a couple of really painful points in BEHAT 2, even though it was extensible. I couldn't write extension for them. And I couldn't find where I should plug new behavior without actually breaking everything for everyone, right? So when I started BEHAT 3, the primary goal for me was not to change the way BEHAT works, but to change how it is extendable. So as soon as people will need some new functionality, I can add it in without the need to introduce BC breaks, backwards compatibility breaks, without the need to refactor or reword the entire system, right? In order to understand extensibility, you kind of need to go into dictionary and definition. So one of the greatest dictionaries of all time, Wikipedia, has this definition of extensibility. Extensibility is a software design principle defined as a system's ability to have new functionality extended in which the system's internal structure and data flow are minimally or not affected. This kind of is aligned with my understanding of extensibility, which is open-closed principle. Software entities should be open for extension, but closed for modification. It means you should be able to change how things work without changing what things are, without actually changing the structure of the code. Without changing the code itself, you should be able to add new behaviors to it. And that was my biggest promise for BEHAT 3, or the goal that I wanted to achieve with BEHAT 3. The second promise of BEHAT 3 was stop doing backwards compatibility breaks, right? Whoever follows BEHAT since version 2 knows that I have this tendency of promising things that I don't follow. So when we released 2.4, there was a big BC break for 2.0 users. And I tweeted this thing there back then saying, sorry for all BC breaks, that is the last time. And then a year later, I wrote this, which is like, welcome to BEHAT 3.0, sorry there's a lot of BC breaks. So the goal for me with BEHAT 3 is to actually follow to my promise and make BC breaks go away as much as it's possible. They always will be there, but how can I mitigate them in the best possible way? So BEHAT 3 at its core is extensibility has extensibility as a core concept, backwards compatibility through extensibility. The second phase is really a little bit vague, but I think it will start making more sense towards the end of the talk. And I will go into details and examples of this. So if you think about extensibility in the Symfony, or dependency injection container, the thing that strikes you first is Symfony bundles and BEHAT extensions. That's how we extend our applications, right? We add new Symfony bundles, we add new BEHAT extensions to BEHAT, and this is how things are growing. The things that not a lot of guys know is that how Symfony bundles actually work inside. So you know that there is a container, and you know that services are hooked into container. What you don't probably know is that there are more than one container when Symfony creates your application. So if you have 5 different bundles registered in your kernel, what Symfony does, and BEHAT does in his world, it goes through each bundle, or through each extension in BEHAT case, creates a temporary container for each of your bundles. It asks your bundle then to fill temporary container with new services. The reason why there is this separation between bundles is because Symfony doesn't want bundles to conflict, right? So first it creates separate containers with all the services for a particular bundle, and then it merges them all together into one and goes through this compiling phase where there is one container, it doesn't have real services, but it has service definitions. I wouldn't go into more details about this, but the thing you need to know in order to understand this talk is during compiling phase, those guys are called. So there is this thing in Symfony dependency injection container called compiler pass. So as soon as the multiple containers merge into one, Symfony goes through your newly created container and applies compiler passes to it. There is no services, there is no objects instantiated for your container, but it has all the service definitions from all the bundles all over your application. Then those compiler passes modify those service definitions, change them as they see fit in order to enable all the extension points. That's the primary way we will enable any extension points from this point on. Okay? The way you register compiler passes in your Symfony application is inside your bundle, you have a build function, you override it, call the parent one, and then do container add compiler pass, and just pass the new class name, the custom class that you have. Okay. So BEHAT version 3.0, version 1.0. That was my first attempt to do extensibility. And challenge was, as I described, make BEHAT as the most testable framework ever, right? And obviously, I had a code base, I had a problem, I wanted to make it extendable. So I started to look at the patterns that I was most familiar with, or the patterns that I was using a lot. And the first pattern that struck me, and I thought, that's a nice idea, is observer. So observer pattern you mostly know about as like event dispatcher. The thing that you probably don't know is observer and event dispatchers are slightly different. Observer is more OOP or OOP pattern, whereas you just have an interface which defines messages or events that could happen, and then your actual object says, okay, here's the method call, here's another method call. And then your listeners actually implement this concrete interface and depend upon. What Event Dispatcher did in Symfony and in other frameworks, it just generalized this problem. So now you have like central container for all your events where you push events and it's responsible for dispatching them for arbitrary objects. So BEHAT 2 was dependent on event dispatcher, and I decided, hey, what if I change the messaging paradigm inside BEHAT and make everything an event, which is sent to event dispatcher? So here's an example. Here I have this like thing called hook dispatcher. What does it do? It dispatches hooks for BEHAT. So in BEHAT, it is a testing framework. So like before or after test, something could happen, and the something is hook that you register. So how does it work? Hook dispatcher has this method called dispatch hooks, which called at some lifetime period in BEHAT. It creates new hooks carrier event with all the needed information and dispatches it to event dispatcher. Basically, this guy says, hey, event dispatcher, I want to load all the hooks. I have no idea how you will do this. I have no idea who will do it. I just know that you, event dispatcher, will help me with that. And then this event goes through event dispatcher. Probably some event listener will do something with this event, and then you can get hooks from this event later on. Here's how event looks. So anyone can make this call, add hook. Any listener can add hooks to this carrier, and then this guy can just get hooks for specific event. So there is one listener inside event dispatcher, which actually listens to this load hooks event, and then basically reads through all the events, read through your context classes in BEHAT, reads through all the hooks, and adds them to your event, right? That's it. So it's like completely decoupled system, right? Both parts know about event, both parts know about event dispatcher, but that's as far as things go. How do you make this extension point decoupled in the dependency suggestion container? So you usually have this service definition. You will have exactly the same service definition in Symfony. So you have your hook dispatcher, and we have our context dictionary reader. We're just saying context dictionary reader is tagged event subscriber, right? So we have one service, and we have two event subscribers. So then we have specific compiler pass, which when container gets compiled, gets our event dispatcher, gets all the services tagged event subscriber, and just tells event dispatcher to, whenever you get instantiated, call this method with this service, right? It's dynamic registration. What this compiler pass allows you to do is every time you want to add new event subscriber to the system, you just create new service definition somewhere in your extension or somewhere in your other bundle, and you tag it with specific tag. That's it. Things will just hook, and your BEHAT or Symfony application will just know about this new event listener or event subscriber. Now, this seemed like a cool idea, and it actually worked to the level where you can register new extensions to BEHAT, or you can register a new Symfony bundle if it's your Symfony application. And your extension point will just start working, and then you can disable this Symfony bundle, and your application is still working. It just misses this functionality that you disabled. So in your applications, where event dispatcher or observer pattern is useful? Well, event dispatcher itself, and if you're talking about Symfony event dispatcher, is mostly useful in Symfony. And there is a lot of events that Symfony sends throughout the life cycle. They are on the documentation, you can read through them. You can actually tag your services with event subscriber, and Symfony will automatically register them. There is an out-of-the-box compiler pass on Symfony you can use, which basically does exactly the thing that I showed in compiler pass. So you usually use event dispatcher for things that are framework, not framework agnostic. And then you would use observer pattern for things that are specific for your domain, because you usually do care about events that happen. And the reason why you would use observer in your own domain code will become a little bit more apparent as I describe this architectural choice of mine of using event dispatcher as a messaging paradigm in BEHAT2. So in BEHAT2, I basically said I use pub/sub as an architectural choice. And as you could imagine, it didn't quite work. So even though I produced like pull request, I opened like pull request called BEHAT3 release candidate 1, it didn't feel right. It was really, really hard to follow this code, and it was really, really hard to understand what it does. And there is one really good reason for that. I was focusing on this guy. I was focusing on eliminating coupling. Coupling is a degree to which each program module relies on each one of the other modules, right? It's like dependencies, things that we discussed in the morning. But the thing that I missed is this guy has a sister, cohesion. And cohesion is a degree to which the elements of a module belong together. What does it mean? It means that something that will change together, something that will evolve together, a couple of modules that belong to each other should live with each other. So if you look at this code and you think about coupling, okay, we have no idea how those hooks will be loaded. So we'll probably have low coupling at some extent. But then if you look at cohesion, there is a core concept here of loading hooks from somewhere, and it's completely missing here. As soon as we want to change how hooks are loaded or what hooks are, we will need to introduce change both here and in this place that we're needing the hooks. Ideally, you would want a system where you have really low level of coupling, but really high level of cohesion across your modules. And I kind of broke both of the rules, because even though I said the coupling was low, there is a coupling. Every single module in my system was coupled to event dispatcher. It is one couple, but entire system was converging into this one point, which is event dispatcher, which is a problem. Because if you imagine the case where in Symfony 3.0, Fabian decides to change the interface of event dispatcher, BEHAT3 kind of gets screwed. So I decided to scratch this idea, as any software engineer will do. I didn't rewrite anything from scratch, I just refactored. So that's my saving grace. So I came up with this thing. I basically refactored it, and refactored it with a very simple idea in mind. There is no single solution for extensibility, because extensibility is not a single problem, right? Extensibility is a way you provide extension points for the different problems in your domain. And the problems are different, they look different, they act different, and extension points should reflect this difference. They should be different on their own. So right now I will go through a couple of examples of how I tackle different problems in BEHAT3 and how I provided extension points for those problems. So since version 2.5, or maybe even earlier, to 4, BEHAT has some very important extensions. So there is this Mink extension and Symfony 2 extension. Symfony 2 extension, as you could imagine, tells BEHAT what to do with Symfony. Mink extension tells BEHAT what to do with web crawlers. And both of them extend core flows of BEHAT. They extend how BEHAT actually reads your tests. So we have a problem. There are multiple possible algorithms for a single responsibility, right? So there is single responsibility in BEHAT, read me a test file. But then we have multiple guys that are interested in this reading and can extend it. So there is this pattern, which is not really a pattern because it's not in gang of 4, but we use it a lot in Symfony, delegation loop. So there is a delegator pattern, which also is not in the gang of 4, but what it does essentially is you're saying your object is not responsible for solving your problem. Your object is not a solution, but it delegates all the questions somebody asks to another object. I think the primary reason why this guy is not in gang of 4 is because it's kind of very similar to multiple patterns in gang of 4, like facade, for example, not the Laravel facade. The way we use it in Symfony, we use delegation loops. So not one delegation, but multiple of them. I think it will become really easy to see when I show this example. So in BEHAT, I have this thing called Environment Manager. Environment Manager has a list of handlers on it. You can register them through this method. And then there is build environment and isolate environment methods, right? So the way they work, they iterate over all the handlers. They ask each handler, can you do something with this suite that I pass, or with this environment that I pass? And if the guy says yes, then it calls it. So that's delegation loop. That's how Symfony does 30% of its extension points. So then you have this environment handler, which is simple interface. You can implement this interface, and then you create your service definition in the container, like this. You tag your service with environment.handler, and it gets registered automatically. The way it works in both Symfony 2 and BEHAT 3 is that there is a compiler pass, as you might guess. So the thing it does, it finds all the services tagged environment handler, iterates over them, and adds method call to original definition, right? So now you can create your new Symfony bundle, put new responsibility there, or new handler, or new voter in Symfony, tag it, and it will be automatically loaded by your framework or by your dependency injection container without the need to couple those things even on the configuration layer. So where delegation loop is useful? Well, whenever you have predefined problem, but you don't have predefined algorithm. So as in case of BEHAT, you have predefined problem of loading tests, but you don't have predefined problem of how would you do that, or what would you do during this stage. So like you can assume that there will be different ways to do this. This is where you introduce delegation loop. So the primary example is Symfony's, as I said, voters. So security voters are services that you tag with specific thing, with like security.voter, I think it is, and Symfony just registers them into the security component. Next problem, BEHAT testers. So BEHAT has this hierarchical structure where it has like feature tester, scenario tester, outline tester, background tester, step tester. And what they do, as you could imagine, they just like test whatever data structure you provide to them. The problem part is that all of them are extensible through hooks, and all of them are producing events, in addition to actually testing things. And by kind of introducing both event dispatcher and hooks dispatcher into each tester, the code of the guy and complexity grows exponentially. So what do? Well, we have a problem, obviously. We need to dynamically extend the core tester's behavior, or rather add additional behavior without changing the original one. And we have decorator pattern for that. So the way decorator pattern works is that you extract the interface out of the guy you want to extend, and then you create a new class which implements this interface and accepts the same interface as a constructor argument. It decorates the original object, and then proxies calls to the original one. So here's an example. There is runtime scenario tester. It tests scenarios. There is 3 calls or 3 methods there. There is a setup, which sets up your scenario testing environment, test, which tests your scenario, and tear down, which tears down testing environment. In BEHAT, those things do nothing, right? Because BEHAT doesn't do assumptions about where it tests and how it tests your thing. It's your context classes that provide this information. So then you obviously have the scenario tester interface, which just defines those 3 methods. And then you have those guys. So this is event dispatching scenario tester. So what does it do? It accepts scenario tester, any other scenario tester as a constructor argument, and event dispatcher. And then when you call setup, for example, or somebody calls setup on this guy, it creates new event, dispatches it into event dispatcher, and then calls the base tester setup and returns whatever it returns. Tear down works exactly the same way, but for the different event. And then your test, there's no events dispatched during test, so you just proxies the call to the base tester. That's it. Very simplistic. This guy just does only one thing, or 2 things if you'd rather. It dispatches events, and it calls methods on the original tester. And then you have this guy, hookable scenario tester, which, as you can imagine, does similar thing to even dispatching tester. It proxies the call to the base tester, whatever it is that implements scenario tester. And it also depends on the hook dispatcher. But instead of sending events before and after, it actually dispatches hooks, which is your context methods or setup, tear down, calls, whatever. And again, it does the same thing. It just proxies the call to the base tester. So how do you, that's an interesting one, right? With delegation loops, it was really, really easy to kind of extend it in a dynamic way or write a configuration that makes it very easy to wire things up without worrying. With this guy, with decorators, it's usually hard because decorators usually, on the configuration level, know what they decorate, right? You have 3 classes in the row. One decorates another, another decorates another. It's just like, it's like Russian doll, right? You need to put guys in the proper order. And usually how people do this is like they have 2 bundles, and another bundle provides decorator for the first one. They couple them on the configuration level. So even the classes are not coupled, as soon as you remove the second bundle from their application falls apart because configuration doesn't have required services anymore. It turns out you can do something about it. So again, you do exactly the same thing we did before. We registered those guys as services, but we also tag them as a wrapper, right, with specific order. So order defines in which order they will wrap things. And then we have a little bit more complicated, but still easy to understand compiler pass. So what does it do on the very simplistic level? It takes your original service that you're decorating from the container, or definition for the service. It finds all the services that tagged _wrapper, and it wraps them in each other, creates new definitions in the order in which they were specifying to do that. So this creates your decorator chain dynamically. So the same thing you had before with delegation loops now works with decorators. You can register new decorators. You can create new extensions or new Symfony bundles that provide new decorators for existing classes and will still work. Isn't it awesome? I think it is. So where decorator is useful? Well, it has one primary use case, and it's kind of limited to it. It's whenever you want to add new behavior without changing existing one. Right? You have an object which does something. You want to do something more, but without changing what the original one does. Another possible use case is you want, like the object that you're decorating does something, but without side effects. It produces some output, and you want to fine-tune this output. This is another case where decorator will be useful. Another problem. So BEHAT has this very simple output, if you know it. So it has like feature, which is the highest level of hierarchy, then it has scenarios, and then it has steps. That's it. So How it works, internally it sends events, and then there's like output formatter which listens to events and just prints them out. Very, very simple, right? Simple hierarchy. Well, it is until you introduce things like backgrounds. So background is, in Gherkin, a way to take the first step out of each scenario and just group it into one background in the feature. The way it works is this thing, this step, will be executed for each scenario. It's almost like each scenario will inherit this step. But then, those steps are executed in the right order for each scenario, and they're printed in this order if you just send events. But you need to print them in this way, right? Which is kind of tricky already. But then, your hooks can throw exceptions. And if they do throw exception, they show this exception in the first background iteration and in the second scenario. So there's a really convoluted behavior there, and it's really hard to deal with. And if you think about it, how do you add this output logic into this like tree structure, which is really weird, which is not really like what internally BEHAT is? So the problem is we need to add behavior to complex output logic. And I used 3 different patterns here. So the first one is observer. Again, I used event dispatcher. That's how we send events. So testers just send events like start testing step. Formatter listens to this event and produces some output if it needs to. Then there is chain of responsibility. So chain of responsibility is when you're sending some message or method call or event to one object. And this guy, if it can't handle this event, it sends it down the road to another guy, right? So just like it's a chain of calls. Not the train wrecks you're thinking about probably, but like chain of method calls where one object knows only about the second one, and it tells second one, okay, I can't handle it for myself. And that goes on and on. And then there is a composite. Composite is a way to represent hierarchical structures in your code. Very simple one, right? So it's like you have an object, which is a feature. You have a couple of scenarios in this feature, and each scenario has a steps. So we can represent this event structure or event listener structure as a composite. So our listeners become a tree of listeners. So here's how it looks like. This is a core formatter, which is just an event listener. It listens to all TESTWORK or BEHAT events. All of them. It captures all. And then it has this guy, event listener, registered onto it, which is just an interface. And then whatever event it receives, it tells listener, hey, listen to this event. Do something with it. I don't care. So event listener is a very simple interface, and there is very simple implementation for this. Chained event listener. You register an array of different listeners into it, and what all it does, it just like iterates over them and calls each one. Here's an event, here's an event, here's an event, the same event, right? It just like proxies, like spreads them out. So BEHAT has 2 types of listeners. There are printers, output listeners, printers and flow controllers. So here's the printer, step listener. All it does, whatever it receives the step event, it just prints it. That's it, very simple, right? Received an event about step being tested, print a step out. No logic, no control. But then, how does this background work? Because we know that we kind of print this step before the actual scenario. How does it work? Well, that's why we have flow control steps, flow control listeners. So imagine this composite tree. At the very top of it, at the top of the hierarchy, there is this one guy, which is a kind of filter or proxy. It listens to all events, and it checks, is it a background event? Right? Does the background start? Okay, background starts. Okay, I will not proxy down the road any further events. So this guy controls the flow of events. It knows when it needs to pass events down the road, and it knows when it just needs to capture them for the future use. So all this complexity about printing, non-printing steps, when to print them, is coupled in one single guy, which is his sole responsibility. He knows when to print things. He knows when to listen those things. Okay? Where composite and chain of responsibility are useful? Well, I think it's quite obvious when you have those complex hierarchical structures, right? when you have naturally like tree of data, and they can handle it in a different way, and you want to control how you pass the information throughout the tree, you would want to introduce composite plus chain of responsibility. That usually helps. So next one is very, very interesting. So after releasing BEHAT 3, there is this guy saying like, hey, in my before step hook, I want to access this scenario that's being tested, but I can't. And the reason why he can't, if you look at the code of step tester or interface of step tester, there's no scenario. Damn, I need to introduce backwards compatibility break, right? I need to change this interface, and if anybody, since I introduced BEHAT 3 and will introduce this change, created extension which implements this interface, some decorator, which we discussed before for testers, it gets broken, which is the definition of backwards compatibility break. So problem, we need to introduce backwards incompatible change into the API. And that's something that I'm literally considering doing. There is a pattern for that. It's called adapter. So the way adapter works is very, very similar to decorator. Except with decorator, you both implement and pass the object of the same interface. With decorator, you implement one interface, and you get past object of different interface. Here's how it works in live. So we introduce new interface, newly called interface into the BEHAT code base called scenario step tester, right? And the entire code base from now on will use this guy. We'll use this interface and we'll talk with this interface. Don't look at the amount of methods. I will also reduce this in another non-BC breakable change, but that's another story. And then you have this guy. So this is adapter. Step to scenario tester adapter. It implements new scenario step tester, but as a constructor argument, it receives step tester, right? The original one. So then what it does, it receives the new method calls with additional argument, but it passes calls to the old step tester without this additional argument. That's it. That's all it does. There is one single guy. And now the cool part about it is I can introduce this guy into the system transparently for every user of the system. Here's another compiler pass for that. So the way it does, it iterates over all step tester wrappers that I have there before the another compiler pass does, checks their interface, and if their interface is the old one, automatically dynamically wraps them into adapter and puts them back to container. That's it. So if you wrote an extension that uses the old step tester interface, as soon as I update the interface to the new model, everyone in BEHAT side will use new model, while your extension will still continue working. So where adapters are useful? Well, there is two primary use cases for them. I just showed one, when you want to introduce BC breakable change without actually breaking the system. It's like internally. And another use case is when you want to isolate from the system out there, right? When you want to isolate from doctrine, when you want to isolate from third-party API, this is where you introduce adapter. When you want things to change independently, that's the primary use case for that. Okay? So let me show you a little demo of how really extendable system looks. Okay? So here's the BEHAT 3. So that's a core class of BEHAT 3. That's an application factory. What does application factory does? It creates application. So the way it creates application, it registers a bunch of extensions. Entire BEHAT core, everything that BEHAT does is just a set of extensions to the very small core that it is. So we have this feature that we can run here, which does a bunch of crazy stuff, if you can look at it. So there is a scenario. Each step passes except the last one. It also showed failed scenarios at the end. And also there is a hook before scenario which prints this thing on the output. So what happens with this feature? I'm not changing feature or context or anything. What happens if I find and disable hook extension. Just turn it off. Run it again. There's no hook. It's just not getting printed. System still works, it's just not printed. Okay, there is another thing in BEHAT which is like core concept of BEHAT. Like how do you tell BEHAT how to test those Gherkin features? There is one primary thing which does this. It is a context class, right? There is a context extension. So what happens if I disable this guy? It's like it's the core of the tool. Look, it still works. It's just like it doesn't know how to test things. It doesn't know how to read steps, where to get them, but it's just like it tries. Let me return it back. And then there is this guy, output extension, right? Let's turn it off. Nothing happens, right? It just doesn't print anything. But I have this thing in my terminal which is like in the caller shows if the last comment passed or failed. It failed. It still knows that tests fail. It still runs tests. It just doesn't show anything to you because I disabled output extension. So that's what extensible system is for me. Why is it important? Well, mostly because you as a developer can take any of those extensions and replace them with your own. BEHAT reads things from the context in a very specific format, like reads annotations, this stuff. You hate annotations? Write your own thing. You hate objects? Write closures. You hate Gherkin? Replace Gherkin with something else and it will still work. Another reason, and this is something that I mentioned at the very beginning, backwards compatibility. Backwards compatibility in BEHAT comes from extensibility. This is something that I stated at the beginning, and hopefully it starts making sense now. Everything in BEHAT is extension. It means new features are extensions too, which means new features could be toggled on or off. So think about it. BEHAT follows from 3.0, follows Semver, which means I'm forced by the rules of Semver to not introduce new features in the patch releases. Which also means that every time I want to introduce a new feature, I need to merge it into the new branch, create a new branch, right? Start doing like 3.1 with new features, and now I have two branches to maintain. Every time I find a bug in BEHAT, I need to update 3.1 and 3.0. What if I implement new features? Then I have 3.1, 3.2, 3.3. Right? Now I have 5 branches to maintain. What if everything is an extension? What if every single new feature is extension? Well, then you can enable them dynamically, right? So you can merge everything into 3.0. Every new feature goes into 3.0, but it's just disabled by default. As soon as I increase the tag version or the version number of BEHAT, it just enables dynamically the new extension. Which also means if you're on 3.0, you will not see any BC breaks if I introduce them, if I needed to introduce them. But it also means like if you really want to use this new feature from 3.2, you can just enable it manually. This one is really interesting. It's like this one was really surprising to me at the end. Performance implications. So here's how this refactoring looked from the entire code base level. There is 2 times more objects in BEHAT 3 than there was in BEHAT 2. Value objects are used instead of simple types. So in BEHAT 2, I was using like strings, numbers, passing them around. Everything is an object in BEHAT 3. Everything. So there is a lot of additional concepts throughout. I went crazy with decoupling. I decoupled things so that they become really simple, concise, and readable things. It should be slow, right? Here's like tweets and blog posts and presentations from people. They upgraded to BEHAT 3, and it seems it's faster. How in the hell? Immutability. Not a single object in BEHAT 3 overstates its presence. As soon as I introduce value object, some tester uses this value object, it's done with it, value object gets garbage collected. That's it. Memory footprint went drastically down, which means PHP doesn't need to worry about collecting your objects or tracking your objects throughout the lifetime. So even though I have 2 times more objects in the system, at the single point in time, there is 2 times less objects in the runtime process than there was in BEHAT2. And it wouldn't be possible if my system was coupled. So decoupling and performance issues, classes are slower than functions, please. Another interesting side effect, which I call TESTWORK. So somewhere towards the end of this process of second refactoring, I discovered this very interesting thing. And this very interesting thing was 40% of BEHAT3 code base had nothing to do with BEHAT. Like nothing. They were doing something about testing. They were doing something about environment, isolation, testing tools. But no mention of BEHAT or context classes or anything related to Gherkin whatsoever. Just by decoupling things from each other and creating clear extension points, I somehow created this system where 40% of it are not aware of other 60. So what did I do? I separated them. So now, not only I have the most extendable framework, I believe, testing framework. As a process of making BEHAT so extendable, I actually created framework for creating testing frameworks. Not a joke. You can take TESTWORK. Right now it lives in BEHAT repository, but you can depend on it. You can take TESTWORK, and you can create your own testing framework in no time. And that's not just overstatement. There is one guy, Dr. Klein, I worked with him at KNP Labs. He did that. He took TESTWORK, and he wanted to write his own integration testing tool, something in between PHP spec and PHP unit. He did it in 3 hours. That was test-driven development. And it worked. And it had formatters, it had environment isolation, everything that you do, because TESTWORK handled it for him. And because TESTWORK is not coupled to BEHAT itself. Now the hard question, how do you bring all of this into your project? How do you make your own project something like this? Well, there's 2 simple steps. And they will be controversial, but that's what made BEHAT3 possible like it is. Step number 1, close the doors. Assume you have no extension points by default. Design the system in the way where everything is closed. It means private properties, private methods, no protected, and final classes. Step 2, open the doors properly when you need to open them. Identify the need for extension points and make those extension points clear. Not the inheritance, not just extend this class and add your own behavior. Make extension points clear and isolated. So why private properties? Well, as a matter of fact, Fabian has a lot of words and better way to say this. But back in 2011, he wrote this blog post, Pragmatism over Theory, Protected versus Private. He starts from, I often favor pragmatism over theory. Not a good start. Probably because programming is how I earn a living, but also because I don't have any computer science degree, and what I know, I've learned from my experience. Ooh. And then there is this quote, closing the API allows design flows to be found more easily and gives you the opportunity to evolve your code by creating well-defined extension points. So a lot of people in Symfony community read this blog post. Not a lot of people know the backstory behind it. And it kind of, Fabian touches it. And the backstory is, back when they started Symfony2, they were using protected all over the place, right? All the properties were protected. And then there was this guy in community, Bulat, who went since then to Ruby and new uncovered grounds. But back then, Bulat was really into design, more than anyone. And he said, why don't we make all the properties private? And Fabian was against it, but like a couple of people in Symfony community were kind of for it. So Fabian, by being good manager of the project, followed. The bad part of this is just like I was developing BEHAT back then, and I was extending one of those classes, and I was overriding or using protected property. I went into rage mode. Why would you do that? My tool was working and now it doesn't. And then I talked with Bulat, and Bulat said, dude, calm down. Try to find a way through. Try to find what you need to do. Just like it's an open source project, try to fix it. So I went to Symfony, looked at the console component that got broken, and tried to find a way how I can improve it. And I did improve it. I sent the pull request, which created clear extension points, which both improved design of console component and allowed me to do the same thing I did before in the more beautiful and native way. So closing the door made it possible to reopen it again in the more clear way, where now you can reuse console component, and it's one of the most beautiful Symfony components out there. What about final classes? Same story. As soon as I introduced final classes in BEHAT 3, Stoff was working on this Symfony2 extension, updating it for version 3. And then I make the final classes final, and Symfony2 extension gets broken. And he writes this like, look, I just spent some time doing that. I'm not fixing it for you, right? If you want to make classes final, fix it yourself. So I went and fixed it. So here's what it was. Bundle feature locator. This is the thing that finds features in your specific bundle. It extends file system feature locator. That was the problem. File system feature locator went final. The only thing that it does, it does all the bunch of stuff like finds features inside bundle, and then it proxies the call to the parent. Decorator. That's it, right? Instead of parent call, I just put the original one here and proxy to it. Tests of this thing, together with mocks, went down 2 times. Readability and understandability of this thing went drastically up because I don't need to read throughout file system locator anymore. I don't care how this guy does his work. Only thing I care about is that. And then there is some base locator that does all the job for me. So by doing all of this, I managed to do the most closed, most extensible testing framework. And that's it for me. Any questions? Nobody wants to see code slides again? Nothing like that?
I actually would like to see you turn off more things.
Ah. Oh, come on, serious questions. BEHAT is open source, by the way, so you can clone it and turn off things on your own, if that's what you're into. I'm not judging or anything.
Turn off the clear extension. What happened?
CLI extension?
Yeah.
I don't know, it might break. Obviously, I selected what to turn off, guys, come on. There is dependencies, natural dependency between things. Yeah, so there is dependency to this guy. Obviously, because it's a CLI application. So like it didn't eliminate all the dependencies. Like you cannot turn off everything and it will still work, obviously, because it needs to do something somehow. But there are areas which are, even though you might think they are really coupled into BEHAT, they are not. And you can replace them and you can create your own. Okay? Finally. Yes?
Don't get too hopeful. How long did it take you to do that?
Why would you do that? Why would you ask these questions? So I can film my life. is wasted. I don't know, a lot. Actually, to be fair, it actually was more enlightenment process rather than developing. So I think the right answer will be, I spent a year and a half thinking about it, 2 weeks to write it, right? It doesn't take long to write it, but it does take a lot of research and understanding. I didn't know design patterns as much as I know right now, 2 years ago. It took a lot of learning, but it helped me in the process. I treat myself as a better software engineer now than I was 2 years ago, mostly thanks to this process.
Were there any design patterns that you considered using, tried them out, and then found out that they really didn't work well for you?
There wasn't any design patterns that I threw except Event Dispatcher all over the place. There are some patterns naturally in Gang of 4 which aren't really applicable, but there's not much. Like you can use, they all have some use. And that's kind of the problem, just like the use cases that I have. I didn't show all the design patterns I use there. There is translator there is mediator, there is facade. But they're really heavy and like not a lot of benefits for Symfony applications. It's just like you need to find the problem that you have, or actually like understand that you have a problem. That's the first step. Then go through the Gang of 4 and find whatever fits. That's how it works. Like you can't just apply every design pattern and like hope that it just sticks. And that's, I think, part of the reason why I never threw anything away, because I naturally put design patterns in place which fit, right? You find design pattern that solves your problem at hand, which means like it can't suddenly stop solving your problem. Well, it might if you drastically introduce new features or change requirements, this kind of stuff. Okay?
So what is your solution to low cohesion in observer pattern?
In observer pattern, you want to have cohesion. So the way you increase cohesion with Event Dispatcher is you stop using Event Dispatcher and you start using observer pattern, right? So as I described, Event Dispatcher is like generic thing, generic mess where you register listeners into it or subscribers, and then you throw any possible event into it, and it like decides where to send things. Very generic, right? It's just like cohesion goes really, really down because like you have no idea what happens there. Observer is when you introduce the interface, which like defines messages. Like, for example, user registration. You have like user registrator. And then you have event mechanism, which is just an interface saying like user is registered. Just an interface with one method, user is registered. And then you implement event listener by just implementing this interface and you pass it into the user registrator. That's observer pattern. So you decouple things because you do dependency inversion, right? But at the same time, you have cohesion because your user registration knows about these events and that it dispatches it. Does it answer? Cool. Right. Thank you very much.